Question 1. Which of the following is an example of a wave? We have a few options. A ball being thrown across a park, air being blown by a fan, ripples spreading out on a pond, or a spring being stretched out and held in place. Now, what's the definition of a wave? It's energy that travels without the medium traveling. So it's transferal of energy without transferal of matter. So let's go through our options. A says a ball being thrown across a park. Now in that case, we are indeed transferring energy. We're taking the kinetic energy of the ball at one point and putting the kinetic energy at another point. The problem is we're moving the ball at the same time. The ball is what's carrying the energy. And so in order to move the kinetic energy of the ball, we also need to move the ball itself. Therefore, it's not a wave. Alright, how about air being blown by a fan? In this case, we once again have transferal of energy. We'll get the energy of the air near the fan moving out to far away from the fan. But in this case, once again, it's moving because the air is moving. So in this case, we're having transferal of energy and transferal of matter. So this is not a wave. D reads a spring being stretched out and held in place. It turns out that a spring, or even a stretched spring, is a good medium through which waves can travel. In particular, there'll be one-dimensional waves traveling in the same direction as the spring. But at the moment, it's only stretched out and it's being held in place. So that means that energy isn't actually moving through the spring, and it's not a wave. Our last option is C, ripples spreading through a pond. Now in this case, we have a disturbance in the water, the ripples, and they're moving, so they're carrying energy. But if we look at the water molecules in the pond, they're not actually moving in the same direction as the ripples. They're just bobbing up and down. So in this case, C is a wave, because it's a way of transferring energy without transferring matter. Question 2. What is the medium of each wave? A sound wave traveling across a room. So what particles are carrying the vibrations of a sound wave? Well, it turns out that it's the air. So air is the medium for the sound wave. This is why in space, for example, no one can hear you scream. Part B. What is the medium of ripples spreading out in a pond? So in this case, we're not spreading through air, we're spreading through water. So our answer here is water for the medium. Finally, what is the medium of a Mexican wave at a sports game, for example? Now it turns out that a Mexican wave isn't really a proper wave because we're not carrying energy through the crowd. However, we are still seeing repeated vibrations, or repeated people raising their hands. And so in this case, the medium through which a Mexican wave travels would be the people who are putting their hands up. Question 3. In how many dimensions do the following waves travel? Part A, the light from a candle. Now, when we light a candle, can we see it from only one direction? Or can we see it from just a single plane? Or can we see it from all directions? The answer, of course, is that we can see the light from every single direction, and therefore, it's a three-dimensional wave. Part B, how about a wave traveling along a stretched out spring? Now, in this case, the wave can only travel in one direction, along the spring, and so it's a one-dimensional wave. Finally, what about a shock wave from an explosion? In this case, just like for part A, we can feel the shock wave from any direction, whether we're in one direction or another direction or even above it. So, if it spreads out in all directions, it must be a three-dimensional wave. Question 4. Musical instruments produce sound waves by causing air to vibrate. Now, what is the source of the vibrations in a drum? Drums, of course, are instruments that must be struck in order to produce vibrations. When we strike a drum, that means that the skin on the top of the drum starts vibrating, and this is what spreads the sound, or what produces the sound. So in this case, it's the vibrating skin of the drum which produces sound waves. Part B. What produces the vibrations in a violin? Now, a violin is a stringed instrument, and it turns out the strings vibrating is what causes the sound waves. So in this case, the strings on the violin vibrate when they are plucked or bowed by the musician. C. What is the source of the vibrations in a clarinet? Now, a clarinet is a woodwind instrument. As such, there's a column of air inside the instrument which is vibrating, and that's what's producing the sound waves. So what causes the column of air to vibrate? Well, it turns out that in a clarinet, we have a reed in the mouthpiece. When the musician blows onto the reed, that reed will vibrate. So our answer here is that the reed of the clarinet vibrates when a musician blows into the instrument, and that is the source of the vibrations. This is why if the reed of a clarinet breaks, it'll stop working. Finally, what is the source of the vibrations of a trumpet? Now it turns out that a trumpet, being a brass instrument, does not have a reed. Instead, it's got a special mouthpiece into which the musician has to vibrate their lips, sort of make a noise. When they do this into the mouthpiece, it will vibrate the air inside the instrument that will be amplified through the trumpet, and coming out at the end will produce a sound. So in this case, the source of the vibrations is not a reed or a string or a vibrating skin, but the lips of the musician. Question 5. It is possible to transform the energy carried by waves into different forms of energy. So why is this useful? Well, we know that transforming different sorts of energy is useful because we can turn, chemical energy from gold into heat energy of water into electrical energy, and that's how we power a generator. But for waves, it might not immediately be so obvious. It turns out that the main advantage of being able to transform the energy in waves is communication. Remember the transformations that we went through with the mobile phone? So it's easier to transmit some forms of energy than other forms of energy. Electrical energy is very easy to transmit, whereas sound energy is a little bit harder because it spreads out and it's difficult to funnel it in just one direction. So when the energy of a sound wave, for example, is transformed into electrical energy, we can take that electrical energy and transmit it over long distances without losing much energy. Once it's at the destination, we can once again transform the energy back into sound energy. So this means that the waves that we started off with have been transformed into different waves and then transformed back to sound waves. And so because we can transform the energy into different forms, we're able to transmit messages carried by waves much more quickly and efficiently. All right, so that's the end of the questions. In this section, we've gone over what waves are, a bit about how they work, and the advantages of transforming them into different waves. In the next section, we'll be looking at different types of waves in more detail.